All right, we're back. We're still on page 170 because it took me forever to do the rest of the page. And what we're going to talk about now is actually something that's going to be like a little kind of weird for a while because we don't know much about things yet. But it's called eccentricity. And eccentricity is sort of like, you could have like an eccentric uncle or like your eccentric neighbor is always like a plot point in like, I feel like children's books, like children's mystery books. There's always like, oh, that weirdo down the street, like he's an eccentric, he's strange. Eccentricity, I don't actually know if these words have the same root. It feels like they should. Eccentricity is a measure, in some ways, of how much a conic section deviates from a circle. A circle doesn't deviate from a circle at all, so it has an eccentricity of 0, and you should memorize that. And it's easy to memorize because a circle looks like a 0, or a 0 looks like a circle. So then it's a spectrum of how weird things are, right? So an ellipse is less weird than a parabola, and a parabola is definitely less weird than a hyperbola, and the eccentricity just increases as you go. So a circle has a perfect eccentricity of 0. An ellipse will be between 0 and 1. A parabola, all parabolas have an eccentricity of 1, and you should memorize that. And a hyperbola will have an eccentricity greater than 1. So a circle is 0. A parabola is 1. An ellipse is in between, so 0 to 1. Hyperbolas are just like the weirdest, so they're just greater than 1. Let me show you like kind of dynamically how it works. So what I'm going to do is I have a GeoGebra file. For some reason this is not on the web version. It's like on the version that's on my computer. So I don't know. I guess we're looking at that. So here we go. Right now the eccentricity is 0, and what I can do is I can increase it. And you can see it's like it goes from an ellipse. No, sorry. It goes from a circle to an ellipse that you would not be able to tell me is not a circle. Like no one's looking at that and they're like, oh, that's not a circle anymore. But let's keep going, right? Clearly an ellipse at this point. So 0 is a perfect circle. Anything between 0 and 1 is an ellipse. When you're closer to 0, you're closer to a circle. When you are farther from 0, you're like weird. So you are less like a circle. So let me zoom out and you can see it's getting like far more eccentric. It's getting weirder. And then when we get to exactly 1, it becomes a parabola. And that's it. All parabolas have an eccentricity of 1. You should memorize that one. Circle is 0, parabola is 1, ellipse is anything in between. You can move it around and see that. And then anything bigger than 1, you have a hyperbola. So this extra like branch shows up because a hyperbola has 2 branches. And then as the eccentricity increases, the hyperbola like gets closer and closer to just like 2 parallel lines, which is sort of interesting. Like it gets wider as the eccentricity grows. So I guess in theory, if we go to infinity, we might get parallel lines. I don't know. Or maybe we get one intersecting line. Again, I don't really know. But anyway, at 1, it's a parabola. Anything bigger, you're going to get a hyperbola. So it's a pretty vague concept right now. Let me point out something even more vague, and then we will be done with this video and finally done with this page. This page took me forever for some reason. I don't really know. When you are dealing with conic sections, memorize a circle. Like memorize a circle has an eccentricity of 0. Memorize a parabola. It's 1. The other ones you can calculate. You calculate them by doing something called C divided by something called A. That will give you your eccentricity, but we don't know what C and A are yet, so that's not really useful to you. So you don't really need to know that right now. But eccentricity is a spectrum where you have a circle, then you have an ellipse, then you have a parabola, and then you finally have a hyperbola. So this is 0, this is 1, this is anything between 0 and 1, and this is anything greater than 1. So that's going to come up. It's one of the features that we're going to talk about. So circles have an eccentricity of 0. They are perfect circles, and it's a measure of how much you deviate from a circle. So it makes sense. They deviate nothing from a circle because they are circles. Anyway, done with that. We will be back in the next video. Keep going. We're going to learn about ellipses next time. So that's kind of exciting. So I will see you there.